Very good morning. Today we have been discussing about the embedded system design. In that aspect, we could see that certain things have been already discussed about designs. The designs, when you talk about, can be valid to have a hardware or a software designs. Suppose, for example, I want to have a delay has to be introduced. Delay can be generated by software or a hardware. So therefore, this is called as core design aspects. These core designs can be possible and it can be a software or hardware depending upon the requirement and the necessity, and the design engineers has to sit together, sort out the problem. So how fast they want to have the executions of these designs, it matters for them, and the design engineers has to take a decision on this, whether to have the design software means or by hardware means. So therefore, what I would like to say here is that whatever design we have been speaking so far has been valid for a core design, which can be brought down to a level of a hardware. So therefore, the hardware structure can also be suitable for the compatibility with the process, which will be seen too. So we have to look into the features of the process and its specs so that the design can be properly done. So if you see the interprocess communication, we have been telling earlier is that the interprocess, as I said that there are two processes are sharing the resources. One has to have a resource R1, R2, other processor will have R2, R3 and R4, and R1, P1 wants to exchange with R2, and then P2 wants to share with R1, then there is a mutual communication is being needed for the process to understand which process want to relinquish the resource. Therefore, the resources have been shared between the processes. So unless we have a inter-process communication, we cannot able to establish which process is having what resource, and then how the process resource has been shared among the people, and then how the resource has to be attached to the process under consideration. So therefore, the inter-process communication is very, very important for us to understand the communication between the processes so that it can effectively utilize the resources and it can be shared among the processes. So therefore, the inter-process communication plays a greater role in all the aspects. The exchanging of data and control information. Once the processor has been having communication, then it has to go for an exchange of data and control actions can be taken care of. And apart from this, some process can be a concurrent and process can be synchronous. So therefore, the synchronization has been very essential because of certain events which has been taking place. Suppose I have been writing some information and I have a resource called a pen, and this resource wants to be shared by other processes, then it has to go for, it also wants to access the pen, and I also go for accessing the pen. So therefore it has been called as a concurrent activity which has to be sorted out, and there should be a synchronous activity going on. So therefore one has to, it's called a race problem, has to be sorted out in the processes. So therefore, whenever I take care of the pen, I have been going for a critical section. The other process which has been wants a pen will be external to the critical section. So when I relinquish the pen, the other process takes care of the pen and goes for execution. Then the process said to be in a critical section. So therefore we'll see at length and what is a critical section and its importance and where it has been extensively used for the applications. Ensure the order of the executions. So we have to see the executions, how it has been orderly executed and all these things, okay? I know IPC stands for interprocess communication, and memory has to be shared. You know, memory is a resource. Suppose I have process P1, I have process P2, P1 will have 25K, P2 will have 25K memory allocated, but P2 is not using its memory, but P1 wants extra memory, then it can request the process P2 to give some memory to P1 so that the P1 can be executed. So in such occasions, we say the shared memory concept has been coming over here. Not only among two processes, it can be shared by a number of processes. Therefore, the shared memory concept has come here to see that the memory has to be properly, memory is a resource, has to be shared a number of processes and depending on the situation. Then the message passing, as you know that when you want to have a communication by way of a signaling, signal is nothing but a message has to be sent to the devices so that message processing technique has to be adopted, and how the message has to be received, how the message has to be communicated, how the message has to be responded. These are very important factors. What I could see is that message passing will take care of such things. Logical implementation of message passing. So as you know that logic has to be put here, and how the message processing has to take care of, and logically we speak the message passing, and message will have its own message size. That's why when you talk about the fixed and variable message size, every message when sending to other processes should have a queue. The queue will have a fixed or variable message size. So every message when it has been sent, for every message there will be one queue. If I have n number of messages, I have n number of queues. If I have two messages, I have two queues, and which is be destroyed later on. So therefore, the message queues have been very, very important, and message size is been very important. Depending upon that, we can call it as a fixed or variable messages. The message can be symmetric or asymmetric in nature. You know, the symmetry and then asymmetry. Communication can be a direct or indirect. So I can have a direct cable connection or a RF connection, or it can be through different routing. And automatic and explicit buffering. So buffering, when you talk about, is a partial temporary storage, has to be automatic or explicit to the processes. Send by copy or reference. So send by copy when a message has been received. Call by value, call by reference, we can't talk about it. So therefore, these are the extensively used in the C language, and these are the communication which has to be adopted in the interprocess communication. Classification of communication by naming processes must have a way to refer to each other. Okay, classification of communication by naming, the process must have a way to refer to each other. Okay, so every process has to be given certain name like P1, P2, P3, P3, P4, etc., and has to be communicated properly. So types of process, direct communication, indirect communication, what we have been discussing earlier also is that communication can be direct or indirect depending upon the mode of operation, mode of communication. The process must explicitly name the recipient or sender of a communication. So when I want to communicate with P1 to P2, there should be a name of the recipient or sender in the communication link. So therefore, we can say it is called a primitive has been given, send primitive and receive primitive. Send primitive will be P, message, and receive primitive will be Q, message, and this will be send and receive primitives has to be accommodated for processes so that the who is sending, who is receiving will be known very easily. The primitives indicates to me that the type of process and what type of process has been going on, and the process links how it has been connected. So logical links can be established, and switching over actions can also be possible. Properties of a link. Okay, once we want to establish a link between the processes, what are properties of a link has to be understood. So communication links are established automatically. So these links has to be automatically established because it is the automatic operations has to perform. Manually cannot be possible because we have been almost talking about a real-time application where automatic schemes have come into picture, and which takes care of the automatic establishment of the links between the processes. Two processes per a link. So two process per a waiver link should be connected to a two process. one link per pair of process, bidirectional or unidirectional. These links can be a unidirectional or bidirectional. As you know that, you know what is the matter unidirectional, bidirectional, only one way or both directions can be possible to establish communication. Then the issue in addressing is one of the aspects where we could look at it as a direct communication, and systematic and asymmetric, symmetric or asymmetric addressing is possible. And we already discussed about these primitives of P and Q. So send P message with received ID message. So ID stands for the identification of the process will be given here, as therefore we know which, when I send a primitive P and receiving what is ID which has been receiving this message will be known here. By monitoring the identifying and expanding the ID and message, we know that receiver side which process has been receiving it. So no doubt it has been a difficulty. What we see is that the process naming versus modularity has been very, very important. So when you talk about synchronization, and I said synchronous activity has been performed. So simultaneous actions, I read from a memory, I write from a memory. Two processes wants to access a memory for writing or reading information. So it goes for a concurrency or synchronization, but that has to be sorted out as a problem. So what are the algorithms has to be employed to sort out the synchronization or the critical section problems? To ensure data consistency for concurrent access to shared data. So consistency for concurrent access, okay, has to be done for shared data. The various mechanisms to ensure the orderly execution of cooperating process. What is my cooperating process is that the process has to be cooperating process has been there, and process when you talk about it has to share the information and data and from other processes. So there should be various mechanisms to ensure the orderly execution of the cooperative process. The race condition is one where I have been telling that, and I have one resource called a pen. Two processes wants to take the pen. Process P1, P2 is in the race to take, both wants to access simultaneously is called a concurrency. If not, the process P1 will have a pen. Afterwards, the P2 has to wait, and then when P1 releases the pen, P2 will take care of the pen for writing information. So therefore, this sort of race problem has to be sorted out. And how it has to be sorted out is that it has been generally addressed by a mutual exclusion, one after another. I cannot give pen when I have one resource as a pen. I gotta share this pen for both people simultaneously. That is the problem here. So therefore, the race condition problem has to look into properly defining, and where systematic procedure has been adopted so that the race condition can be sorted out. A situation where the outcome of the execution depends on the particular order of the process scheduling, and the critical section problem, which has been already talking about at length. This is what I have been referred previous examples has been a critical section problem. And when we want to go for sharing of the resources, the critical section problem occurs. It is sorted out by mutual exclusion only. Design a protocol that process can use to cooperate. Okay, so I properly do a design. This design can be, I said, a co-design means it has been hardware oriented, otherwise software oriented. So therefore, the design aspects when I talk about is been valid for the co-design or the design aspects. Each process has a segment of code called a critical section whose execution must be. So therefore, the process synchronization when I talk about a general structure for the critical section, problem permission, request to exit, notification of entry, section critical, section exit, section reminder, section while one. So these are the how we write a sequence of instructions when the process is under a critical section. So I said entry, next it goes for critical section, then it comes out from the critical section, then remainder while 1. So this has been the syntax here and has to be taken care of. And next comes the other process will take care of, goes for a critical section. So this is the format where I could see that the problem permission request has been done like this. 3 requirements what I could said is that the mutual exclusion is one solution for this a critical section problem. Only one process can be in its critical section. Now I said that whenever a process wants to share any of the resource, only that process can go for a critical section. When this process is sharing that resource, the other process has to wait. So therefore, only one process can be in a critical section. The progress, only process not in the remainder section can decide which will enter into the critical section. Therefore, when n number of processes are waiting for a critical section, so we have to analyze and see that which process has to go for a critical section. The selection cannot be postponed indefinitely. So see, I cannot go on delaying it. So one has to be taken care of, and which will go to its critical section automatically. So this is the automatic way of going for a critical section, coming out, going to a critical section, coming out. Just look at the n number of processes want to share one resource. So how it can be possible? So this resource has to be shared by n number of processes. When one process goes for a critical section, it makes use of that particular resource. The selection cannot be postponed indefinitely. That's why what I've said that every process needs the resource has to be shared. Bounded waiting. Okay, so there is a bounded waiting time for that. A waiting process only waits for a bounded number of processes to enter the critical section. Okay, so waiting process only waits for a bounded number of processes. Okay, so there is a fixed number of processes waiting for share the resource, and when share the resource goes for the critical section. Okay, so like that we could see that the IPC has been very, very important here, and it has been taken care of properly either by design or co-design aspects, and by sitting together, the engineers will decide whether to go for a software or hardware means of designs so that the process can fit into the specs of the controller which has been selected for the design. Thank you very much.